Silicone-controlled rectifiers. How do resistive and resistive-capacitive trigger angles actually work? Well, we know there's two very basic methods of SCR gate control, and these two methods utilize the AC source as the power source for the triggering of the gate. We're going to focus on the resistive first. With resistive gate triggering, we're connecting the gate of the SCR to a diode and then back to a resistor, which connects to the other side of the AC supply. Because we have a diode in this circuit, it means that current will only flow one direction to the gate terminal of the SCR. And if we were to superimpose the volt AC sine wave, the positive alternation, we can then start to see what happens with the current that will flow through D1 or the first diode. Now we're going to put an ammeter in this gate wire as well as give it a threshold rating of 20 milliamps. We need to achieve 20 milliamps in order to turn on this SCR. If we don't reach 20 milliamps, the SCR will not engage and it will not conduct. If we set the variable resistor to a high ohmic value, what we will see from Ohm's law is that as the voltage starts to increase, so will the current that flows through R1 and through the diode. Because it is a high ohmic value, we will see a low current that will flow through the resistor and through the diode. Now, remember, we need to reach that threshold of 20 milliamps. And when we set the ohmic value to extremely high, we will see that we get a low current value. And the low current value will only reach the 20 milliamps once the voltage is at its peak value, or 90 degrees. In this way, if we set the ohmic value very high, the SCR would be triggered at 90. On the other hand, if we were to adjust the resistance so that it is very low, due to Ohm's law, we would find that the current value that flows through the resistor and the diode is quite high. And with that in mind, we can see that the SCR would be triggered much earlier. Remember, achieving that 20 milliamps only turns the SCR on. And so because of that, with resistive triggering, we're only ever going to be able to have control from full power to about medium power, or 1 degree to 90 degree phase shift or phase trigger angle. With a capacitive resistor triggering system, we are again using the AC supply as a power source in order to trigger the gate, but it's a little bit more complex. In order for us to understand this, we need to remember that in an AC circuit with both resistance and capacitance, the voltage or the capacitor voltage will lead the source. So we have source AC and capacitor volts AC and the gate trigger minimum. The capacitor is the source voltage for the gate in this diagram. Varying R1 will determine the time for the capacitor to charge to the minimum gate voltage and thus cause the threshold current to flow through the gate terminal. When we first have a positive alternation, the capacitor is going to be charging. The gate voltage has not yet been reached and we do not have enough current flowing through the gate. Once we reach the value of voltage that the capacitor has charged up to, the current will flow into the gate and cause the SCR to go fully conducting. The SCR is now on and load current flows through our cathode and anode. Disregard the direction of my arrows in this particular series of slides. It will continue to conduct until the sine wave reaches zero, at which point it naturally commutates, voltage and current both drop to zero. But wait, isn't the capacitor still charged? And the answer is yes, it is still charged. And in order to prevent it from triggering initially again immediately, what we need to do when the polarity reverses is to discharge it. The discharge path is actually through diode 1, and it also does go through the load. The system would then be ready for the next positive alternation, and we could start the triggering sequence again. Due to this, a capacitive resistive triggering system can go anywhere from 1 degree all the way up to 179 degree, providing a full range of power control on a controllable DC output rectifier.